we're done.
Perfect.
Oh, what happened? Oh, okay.
And that's it.
Hi, my name is Jose Hernandez.
My name is Bryan Garza. Today we're going to try and reproduce some of our own Prince Rupert's drops, which are glass objects created by dripping molten glass into cold water. As the glass cools, it forms a tadpole-shaped droplet with a long, thin tail. And because of the rapid cooling, the outer portion of the bulb cools instantly, while the inner portion cools at a slower rate. The slower cooling of the inner portion allows the inner part of the bulb to contract against the outer already cooled part of the bulb.
And this contraction allows for a large amount of compressive stresses on the surfaces. While the core of the drop, in a state of tensile stress, making it kind of tough in glass, this compressive stress creates unusual qualities, such as the ability to withstand a blow from a hammer on the bulb, but will shatter as soon as the tail becomes damaged.
As you saw in the beginning beginning part of the video, we did our own Prince Rupert's drops in the lab on campus, where we had all the professional type of equipment. As you see in the video, there's a propane and oxygen mixed tank, which is a very hot flame, which allows us to reproduce this many times very quickly. Since we couldn't do everything in the lab, we tried to just show as much as we could there. We also have, in that video, we shot the lens through one of these lenses. What's it called? The lens?
It is a polarized lens.
What it allowed you to show was you didn't see as much of the flame, you got to see the glass. Here, we're going to try and reproduce it at home. If you want to try to do it at home yourself, we do want to remind you wear glasses. We've had a few explode in our hands and our faces. So next is going to talk to you a little bit about what you need to do it at home.
Right, so some of the basic tools, as you see here, we have everything. First, you're going to need a MAP Pro gas torch. The propane torch doesn't allow for the drop to actually form in its perfect shape. This MAP Pro gas makes it a little bit easier with higher heat output. Next, we're going to be buying some of these 6mm thick rods. They're made out of Pyrex glass, also known as borosilicate glass. They have a pretty low thermal expansion compared to window pane glass and other things like that. This can be purchased at U of H in the Science Building, 2nd floor, really inexpensive. And of course just a container with water, so as the droplet falls it can instantly cool.
And next we're going to do is we're going to show you what it's like to do it at home.
Yep, let's get started. Alright, so the method to heating these rods is very specific, and you have to be very careful on the way you are heating it. So the way I'm going to start here is I'm going to start by heating a pretty good amount of the rod, just to get a good portion of the rod heated up enough for it to drip. After that, I'm going to go ahead and concentrate all the flame onto the bulb of the rod. Now you see I have these brazing goggles on for safety, of course, in case the glass does decide to break in the heating, and also when I'm going to be able to pull it out of the pot. So here we go. I'm going to begin with my torch. Now as you can see, I'm trying to spin this around to get a good even heating on the rod. You're going to start to see a nice bowl being formed in the front. I'm just going to try to heat behind it so that the tail can just come off of it. Right here I still add some heat, but I want to concentrate all of it right on the bowl. Now you can see it's going to start to drip, and I just want to heat the bulb up. I don't want to worry about the drag. there we go. Now you got to be careful. This tip is still very hot. Now I'm going to reach in there and try to retrieve it. Now you got to be very careful because these will break if you grab it the wrong way. There we go. See, we got a nice bulb there. I don't know if the camera's being focused in or not, but you can see this tail, and it's very sensitive. It's extremely thin. If we even nick this tail, scrape it, drop it, it's gonna explode into a million pieces. That's how you make a Prince Rupert's drop at home.
Okay. Now that we've created our Prince Rupert's drop, we're going to show you that it can't be broken with a hammer. It's kind of really hard to hold, but I'm going to try to do the best I can. First, I'm going to try and show you that the same amount of force I can break this glass, where as opposed to hitting this on the bulb, I cannot break it. So let's try to do this as careful as we can and show you if it will break. So first, we're going to use this rod. Put this down. See what happens when I hit this. Breaks. Didn't really hit it too hard. Still broken in a lot of pieces. So now let's try and break our Prince Rupert's drop. If I can hold it carefully. I don't know if you can see that. That's about as good as I could hit it. I felt like I hit it with the same force. Nothing happened. Didn't even crack. Didn't even nothing. It's the same exact form. So I mean, that's pretty strong. Next we're going to do is we're going to show you what happens when you at least just clip the tail. It should explode at a very high. Okay, so now what we want to show is that when we do clip the tail of our tadpole-like drop, what will happen is it'll shatter in a lot of pieces. But first, what I want to show you is on a normal rod, glass rod, it shouldn't shatter into a powder-like form or anything like that. We expect it just to break into two. Pretty simple glass breaking into larger pieces. So we're going to try and reproduce that here real quick. So we broke it, and we have two pieces. So obviously didn't solidify, no Prince Rupert's drop or anything. It just kind of broke in half. So we just want to show you that before we showed you the shattering of the bulb. So now let's grab our bulb. Now the reason why this thing does shatter is because when it cools in the water, it solidifies in a sense that it stores an immense amount of potential energy. What happens is when you do clip that tail, the smallest little damage or fracture to that tail, what will happen is it releases that potential energy from the tail to the bulb. And what it won't happen is it won't shatter into two pieces. It'll shatter into a million pieces and into like a powder-like form. So we're going to go ahead and clip the tail now and show you that it won't shatter like the two-piece, but into a bunch of little pieces. And that's exactly what we want to show. That's the Prince Rupert's drop, and just make sure you wear glasses when you do it.
Alright, so that concludes our do-it-yourself home experiment for the Prince Rupert's drop. I hope you've enjoyed it. If you have any questions, feel free to contact us some way. We might put our email up or something, just in case. Well, one thing I do want to mention is that not every time did the Prince Rupert drop succeed. There were times where as soon as it hit the water, it would shatter in the water itself, or it was close to quenching, but then at the last moment it would explode. This isn't exactly down to a specific, well-calibrated science. It has to be perfect conditions for the bulb itself to form. So don't get discouraged. You know, we were discouraged at first from doing this. We used a lot of different tanks. We started with a propane tank, went to the MAP gas. We even went to a brazing kit, which was a MAP gas with an oxygen tank, but found out that was way too hot. And you did form a Prince Rupert's drop, but it didn't have the same quality as the actual Prince Rupert drop that was formed perfectly from this torch gas and a 6mm rod.
Just to reemphasize, it's really fun. It really is. But you are working with a lot of dangerous things in the sense of the torch is really hot, and when the glass explodes, it's not fun to have it in your face. So make sure you wear goggles of some sort and just have fun trying it yourself.